Fruling, aka Cozy Azeroth here. I am working my way through an old TI-99 4A TI Basic programming book, 101 Programming Tips and Tricks for the Texas Instruments TI-99 4A home computer by Len Turner. I'm up to program number 89, which is a screen filler. I'm going to read the brief program description, get into TI Basic and the Classic 99 emulator, which emulates a TI-99 4A on a modern PC. Get into TI Basic from there, type the program in, run it, see what we can learn from it, and see what we can make it do. Okay, program number 89, screen filler. Some say it looks like outer space, maybe a view of Earth from out there. Whatever, it makes a fun, colorful display. Alright, this is a very short program, so this will not take very long to type into TI Basic. Let's get into TI Basic. Here's the TI-99 4A start screen. We're going to press any key to begin, press 1 for TI Basic, and let's get typing. 10, call clear. 20, looks like we're going to define a custom character, call CHAR. Character number 128, and it looked to me at a glance, yep, looks like 16 Fs, so just a solid block. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is a solid 8x8 grid with all of the pixels turned on in hexadecimal. That's what's happening there. 30, call screen 10. Okay. I think that's a shade of blue if memory serves. 40, C equals integer of 33 times R in D. Excuse me. That's probably C for column. Okay. If C is less than 1, then 40. If C is less than 1, then 40. 60, R equals integer of 25 times R in D. And then we can do the same kind of error checking here. If we get one that's less than 1, we got to go back to line 60. So 70, if R is less than 1, then 60. If R is less than 1, then 60. 80. This draws the character to the screen, call HCHAR. R, comma C, comma 128. So row, column, and then character number 128, the one we defined above. 90, go to 40. Okay, well, let's see what we get. We don't have any call color statements, do we? So we're just going to be printing, looks like black characters onto the screen. Probably would have jazzed this up with a little more color if I had written this program. Let's skim it real quick, look for any typos, math errors, syntax errors, anything of that sort. Nothing seen. So let's run the program and see what we get. So this is basically going to fill up the screen one block at a time until everything is filled. Yep, as the name indicates, screen filler. Kind of looks like Tetris at a certain point. There we go. Let's get a screenshot of that as it's filling in more and more progressively. Almost a maze generator too. I can imagine something similar to this being used to generate a maze procedurally. There we go. I'm curious how long it'll take to actually fill the screen. Let's let it run for a minute and see if we can get the screen mostly full. It'll take a minute because, you know, as the screen starts to fill, more and more of the dots are going to appear where they're already black dots. So we have to wait for it to randomly generate that one that you need to complete the screen. So we may or may not take time to do it. We'll see how long it takes here. You can probably mathematically compute how likely it is for it to fill up the screen and the average amount of time that it will take to fill up the screen. I'm not going to do that right now, but it would be an interesting calculation to see if you could figure out, as this starts to wind down, how likely is it that it's going to fill the entire screen. Or appear in a spot that's not already filled. It's kind of fun as it starts to fill up. I'm just taking a few screenshots to potentially use as the YouTube thumbnail here. Yeah, you can see the red dots are starting to whittle away here. I like these kinds of procedurally generated graphics.
I like it.
It was just filling in one dot at a time until the whole screen fills, and it's generating the dots randomly. So as the screen gets more filled with black dots, it's going to take longer and longer for it to find a spot that hasn't already been filled. So I'm going to let it run for a minute and see if I can fill up the entire screen or not, and see how long it takes. I haven't been setting a stopwatch or anything, but you guys can figure it out if you want, whoever's watching this. As we get down to the end, it might take a little while for that one dot to be filled. But I've got I've got about 10 minutes to spare here, so we'll see if it happens in 10 minutes or not. Then I've got to move on to other things for the day. While this is running, if you happen to be watching this on my YouTube channel, be sure to check out the rest of my YouTube channel. You can find it under Cozy Azeroth, which is my handle on Twitch, a little nod and a tip of the hat to my favorite modern game, World of Warcraft. Or you can find it under my real name, Zachary Fruling, and on that channel you can find lots of TI-99 4A content, retro programming, retro gaming, lots of World of Warcraft live streaming, and miscellaneous educational videos on a wide variety of topics of interest to me, both professionally and personally. If you're watching this on YouTube, also check out my Twitch channel. It's under Cozy Azeroth, as I mentioned, for live streams and all the above. If you happen to catch me streaming live on Twitch, feel free to say hi and or participate in the chat in any way you see fit. And in any case, whichever platform you're on, be sure to check out the other platform. And I appreciate likes and follows and especially subscriptions, which do help me out greatly. That said, let's get back to just watching this pattern slowly whittle away here. We're getting there. It's mostly filled in with black at this point. We're still losing red pixels, pixel by pixel here, or character by character. We'll see if it's 2:03 p.m. my time right now if you're watching this live, and at 2, we'll give it till 2:13, and then I'm going to 10 more minutes, and then I'm going to give it a ended whether or not this is actually filled up. But you can see it's taking longer and longer to find a position where there hasn't already been a dot filled. I don't know why the author chose red either. They've chosen a prettier color. Maybe he just liked red. He's done that a couple times. Everyone has a favorite color. Yeah, this was a common way of generating a star field as well. You generate, say you have a loop that loops through, 20 times or 30 times or 50 times, and generates a little asterisk or whatever. It's a common way of getting stars on the screen. We've got 9 minutes to go. We'll see if we're going to fill up the screen here. It's taking longer and longer for these red dots to go away. And because there was no randomized statement, this is going to run exactly the same every time you run it, unless you added a randomized statement. I don't think there was a randomized statement, was there? No, there wasn't. So we could add a randomized statement, then it'll, give you a totally fresh batch of random coordinates every time the program is run. Yeah, look, oh, there went another one, okay. Taking longer and longer. There's another one. There goes another one. And another one. Only a few more to go. There's another one. Another one, another one. Another one. Okay, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 left. 9. 8. 7. 6. 'Painfully slow now. 5. Still going. Just drawing black squares behind the scenes. You can't see them because it's drawing them on a black background now. Randomly. 4. Getting there. Think we'll do it? 5 minutes to go. I might let it run for another minute if it's if we're under the last one. 3. Getting there. This whole stream has been going for 12 minutes, so in under 12 minutes we've filled the whole screen. Almost. 3 more to go. Just a matter of time. But it could be a very long time on the last one. There's no guarantee it's going to happen anytime soon. Each roll of the dice, so to speak, is a new attempt. It's the gambler's fallacy. Just because it hasn't happened doesn't make it any more likely that it will happen. Maybe over an infinite number of tries it does. 3 to go. That sound in the background is a printer running. We've got some printing going on over here. Still running, you just can't tell that anything's happening. Yeah, the last couple of them here are going to be painfully slow, as predicted. May not get them done. If not, I challenge you to load up Classic 99, type this program in. There's a link in the, there'll be a link in the description on the YouTube version of this video to the source if you want to type it in and run it yourself. So, see how long it goes. We still have 3 on the screen, so the last 3 are taking quite a while here. As predicted. Getting less and less likely to get a dot that shows up to cover those dots. Like I said, this is a fun way to generate a star field as well. I'm not sure why an asterisk wasn't used. I guess it wouldn't make it a screen filler then. Okay, the stream's been going for 15 minutes and we still haven't got the last 3 of these blocks covered. I'm waiting with bated breath here. Waiting with bells on, as they say. But we could be waiting a very long time. So, may not get there. If not, like I said, give this a try on your own. I've got plans at 2:30, so I can't let this run forever. Although I should have given myself more time on this one, probably. Maybe we'll do another experiment, add a randomized statement, and type this one again and let it run with a totally different randomization mix. But the nice thing about this is we know exactly how long it will take. You know, we could do the math on the from the time when we started until the end, and every time the program is run as written, it'll take the exact amount of time because there's no randomized statement. So every time this program is run, it'll happen in the same exact sequence, unless we add a randomized statement. Yeah, those 3 dots are still on the screen, still going. Hi, people who are just tuning in. We were running this program in TI Basic called Screen Filler. It's basically the screen started out red and it was generating black squares one position at a time that was randomly generated. And we're waiting slowly for the screen to be completely filled. We've been waiting a while for these last 3 to go away. You can't tell that it's actually running, but one square at a time, the screen is being overwritten with black squares. And there are 3 red squares left that have not been covered yet. We've been going for 15 minutes or so. Still going. I got to end the stream in a minute though, because I've got plans at 2:30. So we'll see if they disappear the next couple minutes. If not, I'm gonna have to end the stream prematurely and give this one another go. We're in TI Basic on Classic 99, which is an emulator for the TI-99 4A Texas Instruments computer, but on a modern PC. I have an actual TI-99 4A on my shelf back there. I just find it easier to stream using Classic 99. It works just as well for most purposes. There's nothing like being on the original hardware, so I do intend to get that set up and with some composite cables and do a video capture device and be able to do some stuff on the original hardware. Just haven't got that far yet. I can't believe we still have 3 dots on the screen. All the way down to number 4 went pretty quickly, and then all of a sudden it was like ground to a halt. And it is working. This program's still running. Haven't ended it. I'm going to give it till 2:20, and then if it hasn't happened by then, I'm going to have to cut and run and come back and do this one again. But the nice thing is, because we didn't add a randomized statement every single time this program is run, it's going to happen in the same exact sequence. So if we come back and do it again, we can find exactly how long it will take. I can just let it run until it happens. Next time, I'll plan ahead. And but if we had a randomized statement, then we can get a different randomization mix every time, and there'll be some tolerance range on how long it will likely take to fill the screen. There must be some math where you can calculate, you know, based on the probability, the decreasing probability that it's going to cover a dot based on the number of dots that have already been covered, how long it will likely take on average. It would be an interesting calculation to do. I'm not going to do it. Maybe I'll challenge myself and to figure out how long it would take. Statistics is not my strongest suit. It's been a while, but I could probably figure it out. But I was doing a countdown for a while, and it was like 10, okay. Then we had 9, and 8 went pretty quickly, and so on and so forth. And now we're down to 3. We've been counting down. Riveting, isn't it? Like fishing. Like watching paint dry. So essentially what's happening here, we're essentially painting the screen here, waiting for it to dry. Yeah, I've got 4 more minutes and I gotta go. So we'll see if it happens by then. Seeing these squares on the screen like this makes me want to program up a version of the game of life, and you know, one of those little evolutionary programs where these little entities swarm around and, you know, breed and evolve and stuff. It's a fascinating little program. There must be a TI-99 version of it. There has to be already. It would be fun to try to program one. It seems to me we're going to be stuck at 3 here for a while. I got 3 minutes to go until I got to go, and we still have 3 dots on the screen. So again, if you're just tuning in, what's happening behind the scenes is that black squares are slowly overwriting the screen 1 square at a time based on randomly generated coordinates, or waiting for these last 3 dots to go away. It will happen. My wishes have nothing to do with it. The sequence is pseudo-random right now, so whatever, however long it was going to take, that's how long it's going to take. It would have been interesting for the author to have put in the book exactly how long it would take. Just to demonstrate that it's pseudo-randomness, not real randomness. I'm a little genuinely surprised that it's taking this long. I knew it would grind to a halt, but it's gone really slow. But if we have, you know, 32 times, let me do a quick little calculation. I'm not going to do any probabilities or anything, but let's just see here. We have 24 by 32. There's 768 possible positions on the screen. So 1/768th is the probability of it filling any one of those dots. So taking a while. We could, I'm going to look at the program real quick. Yeah, there's no for next loops, there's no delay loops here, so it's happening pretty quickly. There's very little we could do to speed this up. It would be interesting to write a program that automatically loops, like when the screen gets totally filled. You know, write a little, you know, check to see if whether the whole screen has been filled with black squares, and then start filling it with a different color of square. That'd be a fun little screensaver type program. People watching must be thinking, "You're a fraud. There's no program running." It is running. Just the odds have not been in our favor. It's kind of fun to think that, you know, when the author typed this program up and ran it, experienced the same exact phenomenon that we're experiencing now, because it's running the exact same pattern. Alright, well, like I promised, I gotta go. It's 2:20 and I've got things to do at 2:30, so I've got to get set up for the next thing I'm going to be doing. I'm actually going to be working on, a friend of mine and I are working on a retro 8-bit style fighting game in Pico 8, so we're going to be live streaming that, so if you're curious to see us do that, stay tuned. We'll be back around 2:30, maybe 2:35, depends how long it takes me to get set up. And I'll be back soon with more TI-99 4A content along with the rest of the programs in this book, all 101 of them. I've been doing 101 programming tips and tricks for the TI-99 4A home computer by Len Turner. And it's taken quite a while to do all 101 programs. So, but I'm on the home stretch. This is program number 89, I think it was. Screen filler, so stay tuned for the next one. The next one in this series is Window Twinklers, so stay tuned for Window Twinklers here in the not too distant future. Probably not today, probably tomorrow, or definitely over the weekend. But in any case, thank you for watching, and I will come back to this one again because I want to let it run and see exactly how long it takes to fill the entire screen as written. So the next time I run it, it'll happen in the same exact pattern. But we might experiment with some randomization statements and see if we can mix it up a little bit as well. Anyways, thanks for watching, and I will catch everyone in the next video.